Well, thank you so much for each one of you who, stayed with us until now. So I will be delivering this one, and I just wanted to share a little bit about myself before I start the presentation. So today, we will be talking a little bit about vegetable grafting as a tool, to help us to improve vigor, yield, and stress tolerance, especially focus on small acre systems. So my name is Milena Oliveira. I am the new extension vegetable specialist here at Utah State University. So I am Josh and I, Cody and Wes. We are one of the sources for you guys. So if you have any questions, please feel free to send us an email, and we can help you with any questions you might have. All right. So as I said, I'll just give you a little bit of myself before we start. So I did grew up in a small farm. So, but not here in the northeast part of Brazil. So I'm Brazilian. I did got all my degrees. I did my bachelor's in agronomy horticulture, a master's in plant physiology, and PhD in agronomy horticulture. So I did work with a lot of crops from fruits, vegetables, ornamentals, but also with row crops, Dryland Cropping Systems. So my whole career is trying to address questions and farmers' needs in terms of dryland agriculture. So I did spend some time in Israel as well, where I studied dragon fruit and also vegetable crops, root-root communication between different crops. But anyways, I just wanted to point that having this perspective of being of growing in a small farm and knowing all the challenges and all the difficulties we have in a daily basis, it's okay. I mean, it opens opportunities for us, to also look for strategies, like different methods, different ways to start growing our crops and being profitable as well. So, since we are gonna start, digging a little bit about grafting, this will be basically, I would say, a high quality overview on the topic. I will be very pleased to answer questions as they arise afterwards. But I just want to start with three major questions, and those are just a few questions that we might ask to any grower, right? So, for example, how many of you have struggled with short season, with cold soils, cold spring soils, So, for example, here in the northern Utah, we cannot plant our tomatoes before the Memorial's Day. So it's very challenging. We suffer a lot with this short season, and then by the mid of summer, we do suffer a lot with heat stress. If not, we would have already had problems with, soil-borne diseases. Drought and salinity are always there in semi-arid regions, so it's pretty hard to address all, the needs that we have, all the problems, that we have. For example, another question that would arise would be like, how many of you have seen plants collapse, in the middle of the season, under high tunnel or especially in the field. So if you have those problems, especially with soil-borne diseases, which, for example, the last question would be, how many of you have, replanted or transplanted tomatoes because you lost so many of them? Melons, watermelons, we do have a lot of problems. So if you answer at least two of those questions, you can answer those in the Q&A. Feel free to answer those, just so we know which kind of challenges you face the most. But if you do have those problems, we could potentially address those using a very simple technique that is grafting. So grafting is not a very fancy technique. You will see in a couple of slides that it has been there for a while already, but not many people know how to use it. Adoption is pretty low. So as I mentioned, is grafting, it is an old technique. It is mostly used in perennials, but it can also be done in cactusea for ornamental purposes or for fruit production purposes. Like as I mentioned, my PhD was on dragon fruit. We were trying to work with different hybrids, and then we just found out that some of these hybrids were nematode sensitive. So we did have to graft those into resistant rootstocks in order to get, the productivity in the cultivars that we were working on, especially the red and the white ones, while the yellow ones are nematode tolerant, resistant. But anyways, here in the US, the technique is still the vegetable technique actually. Grafting on vegetables it's pretty new, I would say. Grafting on vegetables, especially specifically, has been done in Solanasia and cucurbits. For example, Solanasia, tomatoes, bell peppers, eggplants. We can use different rootstocks on different combinations of crops and rootstocks on it. And on the cucurbit, we do have a lot of research on melons, watermelons, specialty melons, and so on, trying to address various questions. The basic definition on vegetable grafting is that it's a high quality, it is a great technique for addressing, issues on high value cultivars, several problems. So we do have, for example, we join two big worlds. Basically, we do have the scion, which brings all the high, quality characteristics and high yield, high productivity. And we join that scion onto a strong rootstock. So this rootstock must be very vigorous. So the root growth must be pretty fast. It might be a very strong rootstock that can respond to various problems, specifically soil-borne diseases, nematode, verticillium, and so on and so forth. So fusarium is also one of the most addressed issues with grafted plants. But again, we semi-arid, going back to, to this semi-arid region, trying to produce under those conditions, very challenging, very difficult. So here, for example, it's more challenging, I would say, than in my country because we do have, we don't have snow, we don't have the cold, but we do have heat all year round. So here the season is pretty short. We do get all the problems in the below ground, all the soil-borne diseases, pathogens, and so on. We do also have problems with drought and salinity. So salinity and drought are together. So once you don't have that water, once the evaporation is higher. So the drought brings the salinity, all the salts will come to the surface. So you do have an increase in the EC over time. And we do have, various other issues related to production system, where I am growing, high elevation productivity, all those various problems, or I would say issues that brings into a production system overall. But why grafting is important? So, and why we do care about it. So the basic, I would say the basic takeaway from the grafting is that wanding, when you cut those two plants, when you cut the rootstock and when you cut the scion, that cutting, that wanding, makes various processes in the plant, and that is called cross tolerance. So the plant becomes actually a little bit more stronger. So it is basically what doesn't kill you makes you stronger. So when the plant overcomes that healing, that wanding, the plant is ready to take the secondary stress, right? So the wanding is the first stress, and then we can add a secondary stress so the plant is ready to go. So vegetable grafting has a lot of benefits. As I said, the top one, it's an IPM tool. So it has improved a lot, resistant to various soil-borne diseases and pathogens. It helps with salinity. So those crops that are in the bottom or in the rootstock, they are selected by this strong characteristics of overcoming to various problems in the soil, in the below ground. So it also has benefits on reduction to temperature and drought stress, improved fruit yield and quality without impacting the soluble sugars. That's one of the most concerns, but usually the literature say, and we also tested in here some rootstocks, and we did not see any significant difference in terms of the rootstock impacting, the high quality sugars. The sugars are pretty high as the same. So the scion does not change the characteristics very often in terms of quality when you are using a different rootstock. So the literature also says that there are various benefits on heavy metal and increase water and nutrient efficiency since that rootstock is pretty stronger, right? Let's touch base also on the challenges. So there are still a few challenges in terms of grafting adoption, especially in the US, since it's a new technique. So the adoption is related to various other components, for example, high transplant cost. So grafted plants do cost 50 cents to $1 more than non-grafted plants. And another issue related to adoption is the knowledge. Some folks don't even know if we can graft, a watermelon on the top, having a watermelon in the top used as a scion and a rootstock used as a squash. So most of people are unaware of the benefits still. So that's why we try to come here and to share the knowledge so you guys can have, more experience in terms of looking for opportunities in this area. So another issue related to grafting adoption is limited availability, I would say. So sometimes the grower wants, or the gardener wants to purchase some plants, but the cost of shipping or where is it produced is so high that you simply give up. So there is also a very important uncertainty in terms of the economic return. And I will be touching base in a few slides on that as well, on the economics component. So you guys can be aware of which components, which factors would affect that. There is also one issue related to order quantity. So some nurseries or some supplies, they do not take very few, amount of plants. I'm not saying that all of them does, but I did not struggle when I tried to purchase a few plants from a company that I'm working with. Hopefully. But we have seen that sometimes these big nurseries, big companies, they want to sell a lot of plants, and the grower just doesn't want that. So there is also issues related to physical compatibility. So grafting is a physical hybrid. Just take this in mind. So it is a physical hybrid because you are uniting two worlds, right? The scion and the rootstocks, and they are basically different varieties, different crops that you are joining. So sometimes there is issues with compatibility and availability as well. So some companies, some supplies do not supply that variety you want with that specific rootstock and so on. So because again, the market is still, expanding. It is a little bit challenging still trying to get those plants ordered and trying to get more knowledge about the technique. So grafting this is just a timeline of the current situation, current scenarios on the technique for vegetables. So it was started in Japan. The technique was started in Japan in 1930s, and it came across the world by simply sharing the techniques and the knowledge and the benefits of it. So it came to the US about 10 to 15 years ago. It is still growing, as I said. Those black and yellow spots in our country, there are places that has at least one research being done on it. As you can see, Utah doesn't have any. We are the first ones trying to address questions related to rootstock selection, season, can we grow them? Can we grow tomatoes, for example? Can we grow tomatoes rootstocks earlier? Here we are trying to address those questions. And if you guys are interested to know more about the research, I know that this will be pretty quick, but I'm very happy to share more details with you, what we have been doing since I arrived here about a year ago. All right. So, which rootstock should I choose? So, because there was a need related to it, a lot of folks were reaching to us and asking. So, a group of researchers, they gathered a lot of information and they put in this website. So, it's the vegetable grafting website, and I can share that with you later. They have several resources. For example, they have this list of rootstocks varieties to use and where, which companies that we can find here in the US or outside. They have the benefits in terms of, so here is the rootstock, and there is also various characteristics, soil-borne diseases, tolerance to some stresses, and so on. If you are interested in those tables or in the website, or if you want more details on that, you can just email me, or right after here, I can try to insert really quick their website. All right. Thank you. So grafting has a lot of techniques. And for example, just really quick, we are not going to dive today into those techniques, how to make those grafted plants, grafting combinations. But for example, for Solanasia, we do have actually five best rootstock techniques, grafting techniques that are used, but the cleft and the splice grafting are one of the top ones. So again, it depends on, which nursery is specialized on it, or it depends on yourself. If you are planning to do it yourself, you can test those techniques. But usually for Solanasia tomatoes, bell peppers, eggplants, both the cleft grafting and the splice grafting are the most common. The cleft grafting, you just cut the rootstock. So here's the rootstock in the second part. We just cut the rootstock in flat, and then we insert the scion, while in the splice grafting, we cut both in a 45-degree angle. We also do use clips and some supporters to hold the plants until they make that connection. And then for it's, we do have various techniques as well, but the most common ones are the whole insertion, and the splice grafting is one of the most common that I have seen here and also in Israel. So before, I was also working with that, with grafting in Israel. So the tongue approach, it is pretty easy. It is one of the most adopted ones for small scale growers. But I would say the splice, I like the splice because it's just a 45-degree angle and it's ready to go in a few days. So regarding the economic feasibility. So again, as I mentioned before, the grafting, technique rely on various areas, I would say. So the first one is the production system. So if the grower is, working with exclusively open fields, or if he also has high tunnels, or both, if you are conventional or if you also do organic, what's your goal? Are you looking for exclusively high productivity? Are you focusing on quality on itself? I do have a few growers that are focusing on high quality because they have been doing this for many, many years. It's a family tradition, and they are very concerned about which rootstock to select. But I would say when you don't get only one benefit, you get one or more, two or more benefits if you are using grafted plants. So another economic point related to feasibility it's severity of, for example, soil-borne diseases. If you do have a lot of problems, if you cannot rotate, if your area is pretty small, so it will be very, very profitable to insert, grafted plants into your operations because it is pretty helpful in terms of the soil-borne diseases. There is also another issue which is related to shipping and grafting manually. So again, there are costs associated with any of those components, right? But it depends on your operations, I would say. There is also the economic feasibility is also connected to, especially with, market prices, early market prices, later on in the season market prices. So, and I have an example. It's just a few numbers, just so you get an overview of, how profitable it can be for a certain operation, for a certain situation, right? The economics, it's also dependent on the rootstock choice, the variety combinations, and again, the crop compatibility. So the current scenarios is that the economics is pretty much unsettled, and that's because it's something pretty new. It has been, there is a lot of effort on trying to understand and address those questions, but it's right now it's still a kind of complicated situation to evaluate. But and is also highly dependent on all the other factors as I mentioned. But again, the current scenarios today is that the adoption is increasing, and it is increasing, especially for small and mid-size scale growers, especially organic and those who use high tunnels. So you do have a lot of problems. You cannot rotate very often. So you do get a lot of diseases, and grafting can help you to solve those problems. So here is just a quick example, and I've got some numbers from a grower. So as I mentioned, we are working in this project trying to evaluate solanasias, tomatoes, bell peppers, eggplants, and cucurbits, especially watermelons, and in the future, specialty melons, in terms of which rootstock should I use, which varieties are more profitable, to Utah, transition between production systems. We are trying to address those questions. And again, if you are more interested, I would be happy to talk with you later on those various details. But again, we started this process, this project about a year ago. We gave away, we partnered with a company called Trihistil. They are located in North Carolina. It is actually an Israeli company that I used to work when I was in Israel. So I searched them in here, hope that, hopefully they were here. And thank God they were here. And then we partnered again, and we decided to explore various rootstocks for growers in Utah. So I did my needs assessment. I met a lot of growers, and we asked them, which kind of varieties are you using? And then we chose some rootstocks. We grafted those onto those. And then we have been doing some trials since on watermelons. This year we are going to start the tomatoes under high tunnels, hopefully. So if the weather allows. But anyways, I gave away a lot of plants. I gave away a lot of transplants to some growers. And I've got a lot of reports from them, and I was very happy. And I can share one experience with you guys. So this is a quick example on the watermelons grafted, and we did use this one in 2025 was last year. And then we did compare the production with the growers standard. So the growers standard is 15 tons per acre. This grower has a lot of problems with issues related to fusarium. He has a lot of problems with salinity and so on. So we gave him away some plants. He tested those, and then he reported back last year. So he's got more than 50% increase in productivity. So he's got 31 tons per acre. He sells those, in the early season for for 32 cents a pound, and later in the season, he sells for 20 cents a pound. Again, when you are evaluating this technique on your operations, you must be aware of components that we cannot, that are specific to your operations. For example, the prices, the market prices, right? And calculating, those, we just got a few numbers here that I wanted to share, but for grafted plants, this grower produced 62,000 pounds, which, multiplying by that 32 cents, he's got a production of, for example, he got an average of 19 or almost $20,000 per acre on, using grafted plants, while non-grafted plants, he just got like $10,000 only on it per acre. So the revenue difference was about $10,000 in the early season. Looking at his productivity in the late season, we saw that there was also a benefit. The benefit of growing the grafted plants late in the season was shorter, a little bit lower compared to the early season, the high premium, prices, but the grower was still profitable. So with the late season, he's got about $12,400 per acre, and the non-grafted plants was about $6,000. So it does make sense for this grower to be adopting this. And this year he's going to be ordering. He ordered already some plants, and he's very happy with the results. Again, here I did not add the prices of those grafted plants because, again, I just gave away. But usually plants cost 50 cents to $1 more compared to the non-grafted. So you have to take in consideration when that per acre when calculating your differences in the end. So one example on stress mitigation is that here in Logan, as I said, we did a trial and we compare the controls. So this is a exclamation watermelon. We compare a control, which was 100% irrigation with drought, which was decreased on 25% on the irrigation. And you can see those increases. Grafted plants, for example, this green one, it's exclamation is a watermelon onto a squash rootstock, and it increased about 174% in yield, which was crazy. Under drought, there was no significant difference, so which means the grower can decrease 25% of the water, and the grafted plants respond very good on that because, again, the very deep root system can suck that water and nutrients pretty easy. Again, we did use another rootstock, which was Carolina Strongback. The first rootstock that I mentioned, the squash one, is a fusarium resistant, and the second one is a nematode resistant. So those growers that tested those, they reported back saying that those varieties did pretty well. There was no difference in terms of soluble sugars, so which means that the soluble sugars were not affected by the rootstocks. The plants still had high quality. So with that said, I would like to thank you all. This is a website for the vegetables production. This is a website for my program. This is a new website. You can go there to find various resources. I know sometimes it's pretty hard to find fact sheets on the USU webpage, but you can go in there and search those easily. We do have several topics and fact sheets related to each topic on that. Please let us know what do you think in terms of your needs. So here is the QR code for the 2026 vegetable production needs. I hope you guys could feel that so I can know better what you guys are looking for. And this is my evaluation. I will be happy to if you guys can answer that.